So I want to talk a little bit about how a moving charge interacts in a uniform magnetic field. Okay, so let's quickly draw a magnetic field. Let's say the magnetic field is going to the right and it surrounds about this much area. Okay, so this represents our magnetic field. Now, let's say we have an electron, okay, coming into that magnetic field perpendicularly. Okay, so what's going to happen is this is actually going to feel a force. This electron, as it's inside the magnetic field, is going to feel a force being applied to it. Now, what is that force? It is the magnetic force. Okay, and this is represented by F subscript M. Okay, now this only occurs when a moving charge has a perpendicular component to a magnetic field. Okay, so that perpendicular word is super important. If it is not perpendicular at all, say they're in the same linear plane, there would actually be zero force acting on it. We can actually determine which direction the force would be acting on this electron. How do we do that? Well, we're going to learn a new hand rule. So again, for left hand, that's when it's a negative charge. Okay, and you would use a right hand for a positive charge. Now, how do we do this? There's lots of different things you're going to find online on certain people's ways to figure out the force, the magnetic force, or the direction of the field, whatever kind of question you're given. And I find some of them fairly confusing. Okay, and I've kind of found one that I really like to go off of, and that is my Star Wars method. Okay, so use the Star Wars method. Now, your thumb, okay, your thumb will be the direction of the charge. And think about it. Whether it's a current or just a single charge on its own, it's in one single linear vector. It's only in one direction, that's it. Okay? Your fingers, okay, all the rest of your fingers, your four fingers, they are going to act as the magnetic field. Okay, and think about it. There's multiple arrows to represent a magnetic field, so you need multiple fingers to represent your magnetic field. And this is why it's called the Star Wars method. It's called the Star Wars method because your palm is the direction of the magnetic force. Okay, so think about Star Wars. You use the force with your palm. Let's see if I can, that's a really bad, but you use a force of your palm and you push someone back who's trying to kill you in Star Wars, I guess. Now, that's why it's called the Star Wars method. So how would I figure out the direction that this electron feels? Something to note before I move on, all these things are perpendicular. Okay, they're all perpendicular to each other. Now let's use the left-hand rule in this case to figure out the force this electron feels. So our thumb will first of all be pointing upwards. Okay, we'll have our nail there. And then our fingers are going to be our magnetic field. So our fingers will be pointing, those are some skinny fingers, that's okay. And then it'll look something like that. So your fingers are our magnetic field right now. Our thumb is that single vector of the charge moving. And again, this would be our left hand here because it is a negative charge. And then this would be our palm. I don't quite know how to draw a palm. Let's just draw something like this. Okay, this would be our palm here. So that means the magnetic field that this electron feels is actually pointing towards you, towards the face, out of the page. So we can represent that with a dot, okay? So this is the magnetic force it feels. So the magnetic force is directed out of the page. Okay, so if I were to put that in here, I might put this little dot and then put the magnetic force. Okay, so our electron would start being pushed towards us out of the page. Let's maybe do a quicker little example again. Let's make this time our magnetic field going into the page. Okay, so if the magnetic field is going into the page, and then let's say we have a positive charge, let's say it's coming down like this. So how would I do something like that? Well, what I'm going to ask you to do is, if we're going to determine which way the magnetic force is directed, you're going to have to use your right hand because this is a positive charge. Again, your thumb is the direction of the your thumb is the direction of the charge, so your thumb on your right hand should point down, okay? And then your fingers should be pointing into the page. Point your fingers into the page. And remember, this is the Star Wars method. Using our right hand, our thumb pointing down, our fingers into the page, you will notice that your palm is facing right. And that tells us the direction of our magnetic force. So your direction of your magnetic force is going, is going right. Now, let's do one more quick example, and let's just say we have a magnetic field going to the right, but this time we have a charge. Let's make it a negative charge, negative Q, okay? Let's say it's kind of going at an angle. What happens then? Well, what's going to happen here is, again, if we go back to our original rules here, this all has to be perpendicular. It's only going to matter of the perpendicular component. So just because our charge is moving at an angle here, we're just going to worry about the component of the y component. So you're still going to do the same thing here. You're going to use your left hand. You're going to point your thumb down because that is the perpendicular component. You're going to direct fingers right because that's the magnetic field, and your palm is direction of magnetic force. So we will be going into the page. That's into page, or screen in this case, I guess. So down with your thumb, fingers to the right, you're using your left hand, so your palm should be facing the screen. So we are going to show and represent that as an X into the page, into page, and that is our magnetic force. So I hope that was helpful. You can take a picture of this if you'd like, or hopefully you were taking some notes as we were going on here, and have a good day.